All right, everyone. Thank you so much for sticking around. We have two more speakers here today. And speaking of legends, our next speaker is John Coene. I've said it once in this conference, and I'll say it again. John is the man. John is the founder and primary software engineer at Opifex. He is the author and contributor to major packages like eCharts for R, Firebase, Cicerone, and Waiter. I didn't even realize how many packages he was involved in until we started looking into him more seriously for the conference. And he's also recently, his new project is called Ambiorix, which is a new web framework for R inspired by Express.js. And it's also important to know that he's also the author of the book JavaScript for R, which can be purchased or is available for free. We'll add that link in the comment here in just a couple minutes. But John, I give the floor to you.
Thank you, Ian. I trust you can hear and see me. Can you see my screen at all, or am I doing something wrong here?
We cannot see your screen yet. I think
you can now, Coene. I trust you can see my screen and all as well. Thank you very much. It's going to be difficult to top the previous talk. Thanks to Eric. It was really great. I kindly asked him not to make the talk too good because I had to follow, but he did not do that. So I'm John. Thank you for the kind introduction, Ian, and I'm here to talk to you about endpoints with Shiny. Let me enter presentation mode, make this full screen. So before we start, at the bottom here, you have the link to the slides. Although hopefully you can see my screen fine and you don't need them. So as I said, I'm a software engineer and I'm founder of Opifex. And I'm essentially the warm-up act for the keynote that's to follow. So I have a few slides, and it's mainly jokes and a few card tricks to get you into the mood. So if you needed this link to the slides, I hope you took note of it. I might share it later on Twitter or something. So let's start. So before we go into the endpoints, I want to cover extremely briefly how Shiny works. It's brief because my time is limited, but also because I wouldn't want to confuse you with my own misunderstandings. So I keep things simple here. Essentially, what happens once you have written your Shiny application, however it is, and you have it deployed on RStudio Connect, Shiny Apps, wherever it is, essentially the client is going to connect to your application by looking up the address, and that makes a GET request to your server function, if you like. And that returns the initial UI block that you had in your application. It's more or less the initial UI block. If you have initial observe and stuff like that that runs on start, that might be included. But overall, that's what you get. One connection, one GET request, and then once that's done, Shiny establishes a WebSocket connection with the server so that you can communicate with it. And all subsequent communication is done via said WebSocket. That is how you pick up inputs when people click on a button, how you change a table, a plot. Pretty much everything goes through this WebSocket. So essentially, Shiny is for what we call generally single-page applications. That is, there's a single GET request, and once the app is loaded, the app is loaded. There's no more loading of the app. We go through the WebSocket. So what do we mean by endpoints? Well, it's very much like what you see on what you do if you've used Plumber. I have a snippet of code here that I took from the website, and that's very much how it works. So you're gonna here open, you're gonna have this function. It's gonna react when people make a GET request to /endpoint. Well, in a sense, with admittedly quite a few caveats, you can do the same from within Shiny. But before I go into how you do that, here are a few examples, real-world examples that actually make use of it. It's not very visible, but if you have the slides online, these are links that take you to the GitHub code, the specific lines where that happens. But DT, the package for data tables, makes use of this endpoint kind of system. So the selectize input, the learner package, and Shiny semantic, which I believe is by Epsilon, incidentally. So if it's used in the wild, it's obviously of some use. It's poor wording of mine, but essentially what I want to say is that it serves a purpose. It's interesting to know, and I think the reason we don't see more of it is simply that there is a lack of documentation. So how do you go about using those inputs? I'll cover the much more interesting why at the end of this presentation. But first, how do you go about it? Now, this may be another reason why we don't see too much of it. Not to take a bash at Shiny, as you know, I do a lot of Shiny. I love the framework, but some things a bit like this here are perhaps not aptly named. So what you do is you use the old mysterious session object that none of us really understand. But on it, there is a method called register data object. And this method essentially allows you to create said endpoint. And I'm doing air quotes here. And it takes 3 arguments: name, data, and filter function. And essentially I find these, particularly last argument, not very memorable. So the idea is that in the next few slides, I just unpack these for you. So I'll do it in reverse order, starting with the filter function. So the filter function is a function that's going to accept 2 arguments. First, the data, and second, the request. And what is it essentially? Well, it's if you like a callback function. It's a function. If you're not familiar with callback, it's a callback function. It's a function that's going to run when we make a request to the endpoint we create. This function is going to run, and it's going to be passed data and the request, and it must return a response. The second argument, the data, well, it's that data that we pass to the filter function. And it's essentially an R object. You can pass whatever you want to it: a data frame, a list of data frame, an SF object, whatever you desire. And then the name, the first argument, is essentially the name of the endpoint, a bit like the example I had at the beginning with a plumber, where you had /endpoint. That was the name of it. If you name it dataset, you would expect to have /dataset, but in fact you do not really get that. And that's essentially in my next slide. Sorry. If you did create the endpoint at the name that you had given, then you probably wouldn't have a return value, and that's the reason you have a return value. So Shiny, as you know, everything revolves very much around this concept of the session. A user connects, gets their own session. And that's why when we both visit the same application, if I move a slider, it doesn't move on your end, or it doesn't filter the data magically on your end. That'd be annoying. So everything is sort of containerized, if you like, within the session. And so we can't just create a new path /data, because then every user that were connected would ping the same endpoint, and it might create a mess. Therefore, Shiny kind of dynamically create that path for us, and it's going to be preceded here like by some what looks like gibberish, but is essentially, to the best of my understanding, some sort of session identifier. So that feels a bit awkward, but it makes perfect sense, I think, within Shiny. So the meat of it is really that filter function. So I'm going to skip over the data object. Like I said, it's just data. Whatever object you want to use when people make a request, you specify it. The request object is something you might be unfamiliar with. You can access it from, for example, Plumber APIs if you use that. But I suspect most our users are unfamiliar with it. And essentially, that request object contains metadata about the nature of the request. So there's going to be headers that contain information about what browser is making the request, as well as many other things. You're going to have the query string, etc. But being the most important function here, I'm going to hopefully take some time in the next few slides to unpack really how it works. So first thing, that function must return a response. Now, it's it's a different paradigm. That's why I had that first slide on describing how Shiny works, and Shiny works with that WebSocket through which we send messages. Here, you're in a different modal, you're in the request response modal. So someone, something, whatever it is, makes a request to your server, and your server must return a response. It can't just stay silent. And that's standard HTTP stuff. That's nothing that's been invented by Shiny here. You must return a response. And you can do it with the HTTP response function from the Shiny package. It used not to be exported, but in, I think, 1.6 it was exported. So you now have access to this function. And it takes 4 arguments, and I have the 4 arguments there, their default, the 4 arguments and their default values here on the snippet of code. So the status code, that's again standard HTTP stuff. You may not be familiar with the HTTP status code, but I think we've all experienced a 404 not found, where 404 is the status code for that. For the resource you're trying to access is not found. If you've used APIs, you may have seen, I don't know, 403 for unauthorized. If you've built such application, or like myself, you probably have generated yourself quite a few 500 for internal server error. That's essentially when the developer messes up. And you have, for example, the default value 200. That means, okay, the request went fine and the response is okay. Then you have the content type. The content type is just to indicate to the client, and the client in this case is, well, whatever makes a request to that endpoint. Here in Shiny, we'll use it from the client, from the web browser, but you could think of anything. You could do that from the R console if you really wanted to. And essentially it gives some indication as to what type of content is to be expected. It's good to know that you have HTML, or that you have JSON or CSV, so that you know how to parse it, how to render it if you're a browser, these sort of things. And then you have the content. Obviously, that's the content of what the response that you want to send. So if it's HTML, you put HTML there. If it's data, you just put data there. And the headers, again, is standard HTTP stuff, but for what we're doing here, we really do not need it. So I'm going to skip it entirely. You can read up about HTTP headers if you're interested. So here are 2 simple examples. So in the first example at the top, we just returned HTML, status 200, the response is all good, nothing went wrong. And we just return content type HTML, and you see that we have H1 tags. But generally, the way you'll use it within Shiny is probably to share data. JSON is a great format for that. So we changed the content type to JSON, and here we use JSON line to JSON encode that data. But a more substantial example, because if you've noticed in the last slide, we don't make really use of data or the request. And the request generally, like I said, it comes with tons of metadata, but you probably want to use it mostly for that query string. So if you've used APIs in the past or built APIs, you know what it is. It's essentially that string that follows the interrogation mark here, and that allows you to pass, well, what we call the query. But it's in the form of a string, and a string is hardly handy at all. So Shiny has this function parse query string that does exactly what it says on the tin, and returns a nice list of these named objects. So here call is going to be equal to mpg, and that's what I can use then here to retrieve just that column, and then return the data like so. So that's kind of what happens server side if you want to create those endpoints. But if you've done all of that, sorry. If you've done all of that, you've created that endpoint, but now we need to use it. And generally, you're going to do that from the client. And thankfully, it's very easy with JavaScript. Now, again, to keep things confusing, I'm going to start at the bottom of this slide. I think it's clear. So if you used HTTR to ping APIs, that's probably something similar that you've done. You've got a URL, you've got the query at the end, and you use HTTR get to get the response. That's literally the type, the class that HTTR get returns. And once you have that response, you want to get the content out of that response. And you use HTTR content. And then you pass it to a function. You do whatever you want with that data. Well, in JavaScript, it's very much the same, except instead of HTTR get, we use fetch. And that returns a promise in JavaScript. That's why we have this then notation here. So that returns so essentially once we have that's resolved, we have a response and we get the JSON out of the response. This is pretty much exactly the same as HTTR content. That gives you data, and then you can do whatever you want with the data. So I'm going a bit fast here. I do apologize. I realize I'm well ahead of time. So I'm going to try and slow down a wee bit, or hopefully there are questions. So essentially, that's how you would go about creating those endpoints and using those endpoints. And one great thing about it here too is fetch is asynchronous. So it's not going to block your code on the client, of course, are still single threaded and everything. Let me take a swig and move on to the next slide. So the big question remains as to why you should bother using endpoints. And the main reason why we have this question, why to begin with, is because there's nothing you can't do with the WebSocket that you can do with the request response server. So if it's just a matter of getting stuff done, there's no need to delve into this new, hopefully new world of request response model. However, I think it's got a few advantages in places. All pros comes with some cons, so we'll look at these two, of course. So the error handling. When I use the WebSocket, is kind of difficult because the WebSocket, you just send a message and that's all you have. But here, thanks to the idea of the response having this status, like we saw the status code and other things that you can attach, means that it's easier for me to handle errors. As you see at the top here on line 3, you have access to the status, or you have a simple Boolean called OK to check if the response was fine. Then again, because it's asynchronous, we can use this then notation that ends in a catch. It looks a bit like a try catch in R, if you like. For intents and purposes, kind of does the same. So, for example, if the response is not okay, I can throw an error and then I handle the error here. If when I do the fetch on the endpoint, something goes wrong and I can't ping the endpoint, it's going to throw an error and everything goes back to the error step and I can handle the errors, which is a lot more difficult to do, I think, with messages via the WebSocket. Then you have code readability, which is a huge pet peeve of mine, but honestly, that's generally what indirectly improves performances. If you can make your code clearer, always do. Otherwise, you find yourself debugging for hours. And essentially, this is on the slide a pattern I actually see or code very often. Simply, we have an event here. It's a button click. And that button click does something and sends some data to the server. The way you do that, at least in Chinese, with set input value, and I give the name of an input. It's not a true input in the real sense of the term, or the shiny sense of the term, if you like. But that's how I'm going to send data to the server. And then server side, I'll observe on that input. I do something, update a database, whatever it is that I want. And then I send a response back with some data. And then I have another place in JavaScript on the client side where I listen to messages of type my response and I react to it. And here there's a few there's a few problems with it, and it's I think it's, to me, inherent to the WebSocket and how it works. It's nothing to do with that with Shiny here. But first, I have an input, a name that I need to track and make sure it doesn't clash with anything. It's even a bit more annoying if you have namespaces and if you use modules, which you should use, as you know. It creates this chain of things that I have to keep track. If something goes wrong, I have to find what's the name of my input, find where it's used on the server, what's in this observer, see that it returns my response, see if that's triggered server side, and I'm very quickly lost. Another thing is this data object. You send a data object, and then you have to generally read through the code depending on how big, well, that code chunk is, to try and see what exactly is the shape, the structure of that data in the end. It may, and that's easy to mess up. You can remove a variable, add one, rename one, and it quickly becomes a mess. Whereas if you look at the same pattern here, I think to me it's much simpler. I have a button click on the left, and then that click sends an event, sender fetches, makes the query. I get a response, unpack the response, get the data. Everything that's tied to this event takes place right here. There's no back and forth that I have to keep track of. If I change what I sent, it's much more difficult to mess it up because I have to, I don't know, if I'm not changing the subtle structure of a data object, it's a string that it feels more explicit. And similarly here, that's also kind of documented. I can clearly see here that I'm expecting a query named call. If I don't have it here, you can, of course, safeguard against it. Here, I don't have this example, but at least it's there, it's documented. It's maybe not, to reword that, it's maybe not safer, but if I break it, it's going to be, at least in my mind, louder. And that's kind of what I mean. When your code is going to have issues, particularly in large applications. I write bugs daily, but the point is I want to be able to quickly fix them and easily find them, and that's how I do it. I find that this method helps me do so a great deal. So it fails loudly. It's more difficult for me to mess up the data structure. I don't have to manage IDs. There's less feeling of a back and forth between server and client. And then for the performances, it's really just a brief note in terms of performance difference between the request response module and the WebSocket. Technically, there's the tiny differences. The WebSocket beats the request response module by, I don't know how many nanoseconds, but we're not talking about much here. But the thing is, this whole adage of if you have a hammer, everything looks like a nail kind of thing, and if you have a different tool in hand, then you come up with a completely different solution. And one thing that I've noticed, for example, is what I have here at the bottom of the slide, where when I have with the WebSocket, I tended to, if I have 50 things to render, whatever they are, card, boxes, tables, buttons, I just render all of them, even though they may not be visible at the time. I render all of them, and then I use the WebSocket to show hide. If you use the request response model, you naturally, I think, work differently. And you're making such, instead of rendering 50 things and then show hide toggling between them, you won't render anything and only render whatever is needed when the button is pressed. And if item number one needs to be rendered, you render it just there and then you're done. I'll just finish real quickly with the limitation slide. You've noticed that here it's really about getting data. We may get request here. If you know how to make post request work in this in Shiny like this, I haven't managed to make it work. If you do, let me know. But here we're making get requests. We're getting data. It's not meant to update something server side. We don't have access to our reactives. We don't have access to the session object. Everything is there in the GET request, at least in my mind. That's what we do here. So I think I'm just about time. So I'll leave you with this. Thank you very much. I'll stop sharing my screen. Yeah. Hi, Ian.
Hey, John, that was such a great presentation, and thank you so much for being here once again.
Thank you.
Um,
You're so polite.
I'll try my best. So I myself just personally have been using Shiny for 7 years, and I feel like I only found out about Shiny API endpoints maybe about 4 or 5 months ago. Do you have any resources, or can you point the people at home to where they can find out more about Shiny endpoints, and if there's any examples of this being used in the wild, so to speak? I know that you put a great YouTube video up a couple weeks ago that explains this with a live example.
I did, and actually I've been using it for a while now. This sort of request response model, but I didn't share that with anyone for a long time because I wasn't sure that it was right. For a long time, you had to use an exported function from Shiny, and I thought perhaps there's a good reason why that's not documented. With time, I've discovered that it's not. And essentially, I heard that first from Kent Russell. You may know him as a Timely Portfolio on Twitter and GitHub. He's done great things with Shiny JavaScript. He was on the Shiny Developer podcast as well. But in any event, he just mentioned that in passing. Oh, you should just take a look. And I seriously haven't found any real documentation. I have the few links that I have shared with the slides. Just said, take a look at it. I did and managed to make it work with this. But I haven't really found any documentation on it.
Well, for anybody watching at home, we're also going to be having another chat tomorrow with Philip Akkad, who's one of the first speakers talking about using React on the front end, and he's going to be discussing this topic again if anybody wants to tune into that. So in my mind, the way that this presentation was structured, you did a really good job of kind of comparing the difference between what people might know of using the session to send things back and forth. And that's the way I approached this for years. Now using Shiny API endpoints, I've been able to use this to return graphs and visualizations. And I found it to be really great to kind of simplify my front end and not have to create a UI output. Can you elaborate a little bit more on how people can use this and what it might look like in their projects?
Well, look, so I really use it in a ton of places, but I'll be honest, I had a great difficult time putting that into Word, and there's a lot of things, as a developer that you do intuitively, but it's difficult to explain. But for example, a silly thing, but it did wonders. You have a table and you have a button to copy a link. If the table is 100,000 rows, you can render 100,000 links, but the link is only needed at the time people click copy. So why don't you just fetch it at the time people click copy? It sounds silly, but if you do that on a large scale with something bigger than a link, then suddenly you see huge improvements in the performances. There's also things like I don't know how to explain, but within an event, with something happening, you just want that piece of information and then render it without leaving that sort of loop, that sort of I'm going to leave it at that because I generally do a poor job of explaining it, and that's why I kind of hope I encourage people to give it a go and see for themselves.
I think so too, John. So one question that we had come down the pipeline is about what you use to create your slideshow here or your presentation.
The very latest Quarto. Which does wonders actually. It's Quarto, and I think it's Reveal.js, which I think I see the comments very much sharing, and that would normally use similar Reveal.js.
Yeah, and for anybody at home, Quarto, Reveal.js for your slideshows. In my mind, that's the only way I'm ever going to structure a slideshow again. So we are coming to the end of the time here, John. For anybody at home who maybe wants to learn more about you or wants to know how to follow you and keep up with what you're doing, where would they find that?
If you want to get in touch with me, there's my Twitter is really probably the easiest thing. I keep the messages are open even if you don't follow me. So never hesitate. I do apologize if you have contacted me and I didn't come back to you. It's generally said, don't feel free to do so again. Sometimes I forget, but yeah, Twitter is probably the best place, and GitHub, of course.
Okay, fantastic. Well, thank you once again, John. We really appreciate having you here, and it's been fantastic to meet you through this process, and we look forward to having you next year.
No, thank you very much for having me. It was an honor, and all the best to you and everyone for the rest of the conference.
Thank you, John.
Cheers, thank you.